So ladies and gentlemen, it is our pleasure to talk to you about multi-agents in action. We have actually built this demo for you that I'm sure you all will be excited about, because we wanted to show you three different agents, three different agent framework, how you call tools, run infrastructure in scale. So my name is Jan. Hello.
And I'm Vini. Hi.
And we are from the Azure Container Apps team. So the agenda, we'll talk a little bit about the what is modern agentic infrastructure and why would you need to care. And then we'll go into demoing the Agentic Content Factory that you're here for. Of course, we will provide you the GitHub repo where you can get it and get it running as soon as we are done. Now, as a matter of fact, maybe you didn't know that Gartner is predicting that 40% of agentic projects will be canceled by 2025. And this is not because the agents or the LLM cannot keep up. That's because of high risk, lack of governance, and that the runtime is breaking. And so what are the challenges of today's runtime? Well, budgets that run unattended. You've probably created an Azure resource that a week later was still running, and you probably didn't need it. Maybe when you were trying to deploy something, you deployed it 10 times, and you have 10 resources, and you forgot to clean it up. It's happening to me all the time. So introducing some type of life cycle of that agentic compute is definitely something that is important. How do you run untrusted code? Anybody is running untrusted code, meaning AI-generated code next to their applications?
No.
Nobody does that, okay. Okay, so that's very important to kind of separate those boundaries, right? Cold start, when an agent does a tool call, maybe to run some script or swarm to other agents, it shouldn't take a minute for each agent to come up because it's waiting for the infrastructure. And then the agentic infrastructure is really not just for short task for just running a code and then disappearing. It also is useful for long-running tasks if you want to preserve the state. So it should have some type of snapshots and allow you to restore to the previous point. And of course, many times, because the area is evolving so quickly, the tooling is many times stitched by hand. And so it is our pleasure to announce Azure Container App Sandboxes. This is a private preview of fast, isolated, and stateful infrastructure on demand. You can go to sandboxes.azure.com and run your sandbox today. As we mentioned before, it executes your code securely. It resumes instantly. You can use snapshots, not just for disk, but also memory. And you can burst to hyperscale. We already have a number of internal Microsoft customers. Microsoft Foundry is hosting their hosted agents is using ACA sandboxes for hosted agents. GitHub sandboxes are using the same technology. And our very own technology, Azure Container Apps Express. It is a agent-first technology that we have introduced recently that allows you to provision in a couple seconds and scale from 0 to 1 around a second. Now let's talk about our fun demo. So we promised you 3 agents. So these are the 3 agents. The first agent is the researcher who researches a specific topic. The other agent takes that input from the researcher agent and creates a content. It writes a blog, it writes an article, it writes some social posts. And the last one creates a engaging podcast based on the content. And because we were thinking that, well, this is how usually projects happen in an organization. They happen from the grassroots, and people use different technologies. So for example, for the researcher agent, we've used LangGraph, Python. For the creator agent, we used Agent Framework, and we coded it in C#. And for the last one, GitHub Copilot SDK. So out of curiosity, is there anybody who tried to build agents with GitHub Copilot SDK as the harness layer. If you haven't tried it, try it. It's really good. It's very easy to get started. In this case, we are using the bring your own AI model. So we are not using the LLM model behind the GitHub Copilot, but we are using one of the Foundry models. And so this is already the infrastructure that is a little bit higher level that shows you on the left. There is an orchestrator that orchestrates the workflow between these agents, and that's what we will interact. So that's what you will see very shortly. Then these three agents are, of course, connected to Microsoft Foundry because they use the Foundry models. And two, we also wanted to show you how you can bring these three diverse models into one management plane. So you can manage them from Foundry, and you can observe them from Foundry and application insights. How did we make it work? OTel is the buzzword, open telemetry. So all these agents and even the orchestrator emits detailed OTel telemetry, so you know what's going on. And all these components run on container apps. So it is time for a demo, and this is a QR code for the GitHub repo. So if you want to grab the link, it's here. It will be throughout the session. So it's aka.ms/ACA-build 2026 demo 312.
As soon as he phones down, we'll go to the demo. Okay, everybody got their GitHub, everybody got their QR code. Let's go to the Content Factory demo.
Yeah.
You want to talk
Thank
about
you.
the
Yeah. So this Content Factory you see, so the interface here that you see, it is the developer, the orchestrator, and the orchestrator, what it does, we've researched a specific topic, a container app, then it did its research, it wrote a blog, and at the end, it wrote a podcast about Azure Container Apps. But, you know, we were thinking, isn't this like too boring to show you, okay, well, what is container apps? So,
yeah,
because
it's very boring.
Vini and I are soccer fans. Do we have any soccer fans here? Probably some, okay. So,
how many wishes it would call proper football rather than soccer?
Oh, I'm sorry, that's what I meant. Proper football,
Thank
yes.
you.
And so because Vini is made in Mexico and I'm made in Czechia, so that's why we wanted to make it also a little competitive, like a game simulator, soccer game simulator between Mexico and Czechia.
Yeah, we all know how this is going to go.
Well, we'll win, right?
Because I wrote the demo.
Okay,
So
yeah, okay.
I don't, just be prepared. So I started the simulation in the interest of time, but this is you will have the code for this and the other demo, both in the QR code. So this UI has 4 different built-in prompts. I already started with a default prompt here. There is a prompt, hey, what if this player plays and this other doesn't play? What if it turns out to be a defensive battle? What if this player from Czechia is in the best form of his life? Or you can write your own prompt. So what's happening behind the scenes is there is 3 agents. The simulator, the researcher/simulator agent, is deciding to fire a number of web searches to get information from the web. Now, there's multiple ways to do this. For the purposes of this demo, what the agent is doing is writing Python code to do that, to go fetch a bunch of information, lineups, latest news, injury reports, etc. This code is being executed in sandboxes. So each of these queries is firing up a new sandbox with sending the Python code, running the code, retrieving the result, and then firing another sandbox to run the simulation. The simulation is getting all this information, pass it to it's another LLM call, and that gets how the match went.
So just to recap, right, what you just, Vinny, said, these sandboxes were not provisioned during the deployment. Well, yes, you can see this is running on Azure. You can do AZD app on this. So the agent, the simulator agent, dynamically creates these resources. It dynamically creates this infrastructure and keeps it up for as long as it's needed.
All right. So let's see. I was hoping it would finish in time, but in the interest of time, we have some pre-cooked result, right?
Yeah.
So in this case,
Okay, 2-2. I can accept that.
this is a
Vini.
very boring and this is wrong. We all know.
Okay.
That
Well, we
so
shall see.
AI
We shall
results should be reviewed by an expert. So this is how the match went. And now we can see some of the sandboxes here. So every one of the blue line items here is one sandbox that got fired with a purpose, right? With a specific purpose. So
one GUID equals to one sandbox. It's equals to one infrastructure that runs the code from the main agent.
I'll explain a little bit about the allowed and blocked in a minute. I just wanted to show you, this is an example of the code that runs in the sandbox. This is a very simple, get the roster for Czechia, right? And similar for all of them. Now, let's take a look at what happened in any of these sandboxes. So here we go to our user experience for sandboxes, sandboxes.azure.com.
Yeah, and you can you can sign in there today and create your sandbox.
So let's see.
That Vini is searching the GUID, and the sandboxes don't have a name because they're managed by code, managed by agent. So you can search by the GUID, and here is the agent.
So here is the sandbox. Now,
and one important thing, you see that this agent is already idle. What it means that it automatically took snapshot, and it's sleeping. So in other words, you're not paying for any compute resources because this resource is idle.
So sandboxes have a lifecycle policy. You can decide how long they stick around. But also, more importantly, you can resume it. So when the sandbox goes idle, there's a snapshot of the sandbox that is persisted. So you can decide your snapshot policy, but in this case, it's memory and file system of the sandbox. So this is the sandbox that run some of the web research, right? So here you can see one of the features of sandboxes is what we call egress policy. Nothing against skysports.com. This is just for the purposes of this demo. We are deciding to block certain URLs from the sandbox. So,
and this is up to you. You can define this egress policy per sandbox, and it could be either deny all and whitelist specific destinations, or it could be the other way around as Vini is showing here. So he specifically has deny on these three sites.
Yeah, but you can go and say default deny and then allow. So it's all the features that you would expect from a sort of egress policy. So this is one of the features we wanted to show. Here is the other. All right, this one came back. Let's see. Oh, now this is a proper simulation. This actually
I
works.
probably need to walk away.
So let me show you guys the code that run the simulation.
So when it runs the simulation, it means that it's running an agent inside of the sandbox, which means that it needs to call what? The LLM, right? So how do you securely call an LLM from a sandbox? Would you use the API key as an environment variable?
Yes, it's super secure.
Well, is it? It's probably not, because why would you give your secrets to the LLM, potentially?
So here's what happened here. So this is the code that run. It gets the API key. You can see where this is going. Where is the code? There's code here that. Oh yeah, we're logging the request. So let's see what got logged inside the sandbox.
Would look like. Yep.
All right. So let me just go up here and grab the GUID for the.
So the point that we want to show you is that there are smarter ways than give the API token, API secret, to the code, to the agent. You can use managed identity because all these sandboxes run within Azure, and so you can use managed identity to securely access any services, whether it's Cosmos, Foundry, or of course Azure OpenAI.
So what happened here is the code that was written by my agent had access to my API key.
Yep.
This is not very good.
This is not great. No, of course.
So how to fix it, right? So yeah, as Jan said, you probably could have used managed identity, but there are some other services that are not running in Azure that you would need an API key or some sort of secret to call. So let's see. In one of our other simulations that we run,
So the safe way to do it, or one of the ways, if you won't use managed identity.
So I click the little checkbox here for secure egress. Let's see what the simulation sandbox on this instance did. So we go here. By the way, it's idle. It doesn't matter. I'll just resume it. That resume was really fast.
It's sub-second.
Wow.
The resume from Snapshot, it's
amazing.
Definitely sub-second.
So here we go. And then in this case, it's the same code, the same, it's just the API key was not present. It was not available for the code that was written by the agent.
So, Vini, how come that it worked then? Because it seems like the simulation agent ran without failures.
Oh, I'm glad you asked, yeah. Why it worked is because there is another feature in Sandboxes called, it's also part of the egress policy, but it's a different egress policy called transform. So in this case, what we are doing is we are telling one of the key pieces of the sandbox architecture that we built is the egress, the piece of the platform that has the final say on your outbound calls, is a different piece of the platform that the part that runs your code. So the code in the sandbox, it's literally has no access to, it's before the pipeline, the code makes the call, the gateway, the egress gateway, can intercept the call and modify it, which is what we did here.
The egress gateway lives outside of the sandbox infrastructure.
So in this case, we have defined a secret for our sandbox.
Oh, there is our AI, Azure AI open key.
Yeah, so this is where we have defined it.
Yeah, okay.
And then we told the sandbox, we told the egress, we configured the egress policy to say, inject that API key as a header to any outgoing calls to this particular endpoint. So that's why it worked. All right. So let's go back to what the other agents did, right? So we talked about, we talked about the egress policy. We talked about transformation. We saw how we resume idle sandboxes. Then the other agents, there's the block agent and the narration agent. We can see the agent wrote a blog post about the match, right? Which is exactly how it's going to go.
We shall see.
Yeah, we shall see. And then the final one is the narration. Let's see, we're going to, because Mexico won on this one, we're going to hear the entire narration.
The stage is set. Mexico against 𝗬𝗫𝗀𝗀. Two prideful nations clashing on the
probably
World Cup stage.
It's a little bit quiet, but
here we go.
Hopefully you guys can hear it.
Jorge Sanchez with time and space.
Nope, anyway.
A tantalizing cross.
Oh,
Gimenez is there. Bang, goal, 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 goal. What a goal. Santiago Gimenez. Mexico rises. The crowd is in rapture. The Aztec drums are thundering. But 𝗬𝗫𝗀𝗀 is not here to roll over.
We're not gonna, we don't want you to suffer anymore.
It's arching in.
And I think this is a great example what you can achieve with Foundry VTT models, right? Because this is all AI generated. So this is just how big you can dream to build your application, augment this functionality into your applications.
Yes. Not very outlandish. It was actually very close to, anyway. So let's, one of the other, this is about the demo. Let's talk about observability. We're not going to show, as part of the demo, how we configure this, but because, as Jan said, we're using OpenTelemetry to instrument all of our agent calls, we can use the inbuilt
hotel collector.
So
the way how we deploy the infrastructure is that there are different container apps that stream the telemetry to the hotel collector that is streaming this data into application insights that is then visible both on the Azure portal and that's exactly what Vini is showing now, but also in Foundry. Because in AI Foundry, you can register all these agents. Remember, these are different technologies of agents. It doesn't matter. As long as they talk A to A or if there's some contract between them, you can register them into Foundry and you can manage them. You can run continuous evaluations or observe these insights.
All right, back to the...
Okay, so So what we have seen is we showed you the workflow between 3 different agents. We showed you how we securely executed the code in ACA sandboxes. And the things to take away is sandboxes allow you to run your code safely. It does not run next to your application, but in physically different infrastructure. You saw how we used the Azure OpenAI API keys that was securely stored outside of the running sandbox, so the sandbox doesn't have access to the code. You also showed you that some of these snapshots, some of these sandboxes were snapshotted and idle, and so you saw how quickly it is to bring them to life. We showed observability and the end-to-end management in Foundry. Now, if you want to learn more about Azure Container Apps here at Build, you can meet us at the booth number 44. It's in the other pavilion. But if you're watching the recording, don't worry. There is a ACA. There is a link that summarizes all announcements for ACA, aka.ms/ACA/build. And we also have a breakout session at 2:45 where you can see more demos, very exciting demos, how our colleague Simon talked to an agent. And we are also showcasing a customer use case. Now, how to start today? Well, it's very simple. Go to sandboxes.azure.com. You can create a sandbox that has, for example, Copilot, and you can start vibing right from your browser immediately. So thank you so much for coming in, and enjoy the rest of your build.
Thank you.